This week on Cloud S.L.A.W, we're going to get into private networks and how to let them talk to things. In Build a VPC from scratch, we create a VPC with two subnets connected to an internet gateway. Now, as I mentioned, this means that any resources in those subnets potentially have access to the internet and might be exposed to threats on the internet coming in from the outside. Anything deployed there is potentially public, which is why, we named the subnets public 1 and public 2. Like, we weren't hiding anything. But by now, I've turned you all into paranoid security freaks, I hope. And you should break out in a cold sweat at the thought of a server touching the internet. It should feel like the fear you experience walking through the wilderness of Alaska, naked, covered in honey and lox, which is a kind of salmon, if you didn't know. The entire reason AWS calls VPCs is because VPC stands for Virtual Private Cloud. The original version created private networks that could never access the internet and only connect to your data center over private network connections. And this led to customers asking annoying questions like, so you're saying I have to route all my traffic, even to talk to S3 and Amazon service, back through my data center, and then out through my own firewalls and out to the internet because the only way to access S3 is on the internet, and even though I can see the files right there in the corner of the building. Yeah, that was a thing. Actually, it still can be, but we'll get there. And perhaps I should get to the point today. We don't want everything to be out on the internet, even though we're using public cloud. And in fact, we want to connect as little as possible directly to the internet because it'll be attacked before I finish speaking this sentence. This is actually really easy to implement in AWS. All we need to do is set the route table of a subnet to not send traffic to 0.0.0.0/0 to the internet gateway. And in those early days of VPCs, we would route that traffic back to the data center, and then the data center hardware would deal with routing it out to the internet. And this was done over dedicated links. And we can still use those, and many big organizations still do. But if we don't route the traffic through the data center, this can cause issues because those private subnets at 0.0.0.0/0 traffic will have nowhere to go. And there's two big ones that you run into quickly. The first is you can't talk to any of the Amazon services. The API endpoints for Amazon services are on the internet. And so if you don't have internet access, you can't actually talk to AWS, even if the actual hardware is all sitting right next to each other in the same building. You also can't do software updates or talk to anything outside of your subnets because most of the software updates and things, they need network access to talk to something to pull down new versions. And that's something especially that people, when they're first getting started and experimenting with AWS, run into really quickly. Now, sometimes this is okay. I've designed architectures that are super secure and deal with these limitations, but they are limitations. So let's talk about network address translation, which is the first way we're going to practice dealing with this issue. Now, right now, I'm recording from my home office, and my house has kind of an over-engineered network. I looked it up right beforehand. I have 42 active clients connecting via 3 wireless access points and multiple hard-cabled connections. These all talk over the internet over one big connection, which is the modem sitting in my server closet over there that has one IP address. And if you kind of think about it, like we're all used to this, but how does that even work? How can these 42 devices share one connection and they all get what they expect to get when they talk to the internet? And that's network address translation. It's been around for a really long time. Everything on my network has a private IP address in the 10.0.0.0/16 range, just like we built last week in AWS. I even have multiple subnets because I'm weird that way and you've met me for my house. My router, using NAT, network address translation, it keeps track of which devices are talking to the internet and what they're talking to. And it handles making sure that all of those requests and responses go back to where they should. It says, translate this private network address into our shared internet address and then track the responses so they can go back to whoever requested it. Okay, let me go ahead and I'm going to do one of my world famous cruddy diagrams to describe this for you. Okay, so let's start with our network. And so let's just imagine that it could be the home network, it could be a VPC. It really doesn't matter what that network is. And we'll put that right about there. Then we have the internet. Oops, let me get the right pencil here. Then up in there, we have the internet here. Now, on my network, I'm going to have my router. Let's go ahead and change the color of this one so it stands out a little bit more. And so let's assume that that's the router. Actually, let me go ahead and change this so it's more legible. So that's my router. This is my private network. And this is the internet. So any traffic, let's say the computer I'm recording this on right now is sitting right over here, and it wants to talk to, I don't know, Netflix out here. And then let's just say there's one other computer over here on my private network, and it wants to talk to Hulu. And the way this works is with network address translation is so these private instances, let's say that one is 10.0.5.4, and the other one doesn't even matter. This is going to go ahead and try to talk to the internet, and it's going to go to the gateway router. That router is basically the connection between my house and the entire internet. Now, technically, there's the router and then there's the modem, and I'm not going to get any more pedantic than that. The device in the router will do the NAT, and it'll say, okay, my IP address is, I don't know, 11.3.5.7. I assume that's a real internet address of some sort. And it's going to talk to Netflix using that address. And Netflix is going to return the traffic back to the NAT gateway, and then that's going to know to route it over here, and it's going to know that any of the Hulu traffic routes over here. And that's all it is. I can have up to my 65,000 private IP addresses in my house, and trust me, I have likely tried to do that. But the NAT will deal with routing all of that traffic. Okay, so how does this work for AWS? Well, let me shift my diagram and I'll show you two examples of it. Okay, so let's take this setup here, and we have two subnets, and this is going to be one of the two ways that this works with. The example that is in this diagram is something called a NAT instance, a NAT gateway. We'll get to the NAT instance in a minute. And the way the NAT gateway works is it's a construct that we create in AWS very similar to an internet gateway. Now, the one big difference that we have here is that this has to have an elastic IP address. So that is a permanent IP address that we actually have to rent from AWS and pay for. And any traffic that is on the internet gateway, in our public subnets, as expected, goes out to the internet and back, just the way we did that last week. Well, what the NAT gateway does is nothing here can have a public IP address. These will only ever have the IP addresses in our subnet range that we are for our private networking. It will never have a public IP address, but it can talk to the NAT gateway, and the NAT gateway is going to work just like I described how NAT works for my home office. There's really no difference. The NAT gateway is doing all the work for us. Now, the problem with NAT gateways is they can be expensive. If I look at my AWS charges, one of the biggest things that I pay for is when I'm using NAT gateways. And you'll see as we go into the end of the lab, I'm actually going to have you delete out everything so that we don't have the charges between weeks, and I'm going to give you infrastructure as code to build it next week. But there's another way of solving this problem, and that is the way that Amazon originally did it, where instead of the NAT gateway, it's what we call a NAT instance. And the NAT instance bridges between the two subnets. Now, specifically, the way it really works is it's actually over there in the public subnet, and my route table would say anything for 0.0.0.0 1/0. If I'm sending it over to the NAT gateway, it's going to be to something called NAT dash whatever that ID is. If it's going to a NAT instance, it actually will say I dash and whatever that instance ID is. And then that traffic routes to that instance that has software running on it to work like to provide network access, network address translation, and then it sends everything out there. Okay, what are the trade-offs associated with these two options? Well, one is with the NAT instances, I've had them crash. I have to deal with patching and updating them. We do pay for the runtime of them, so there's nothing free. Now, if you're on the free tier, you can run a really small one. It's not going to cost you much, but eventually, if you have any modern, any large amounts of traffic, you have to put a bigger one in place. And I'm not saying it's all negative. There's some very large organizations that use these NAT instances because they can run custom security services on them. And sometimes the NAT instance is like a virtual firewall from a major firewall manufacturer that has all of the security stuff on there. But for a lot of customers, they want something where they didn't have to maintain another server, and that's where those NAT gateways come into place. They can crash and stuff, but they do tend to be pretty reliable. But the biggest drawback there is going to be the cost. And this is definitely one of the ones that we have the most common complaints about. It's definitely one of the ones, if I have somebody do labs and they forget to shut things off, this is where they're going to get a larger bill for it. But all that said, if you want a private subnet and you want to have resources that can't ever be accessed from the internet, but you want them to talk to the internet or talk to AWS services, NAT's the fastest and easiest option, and the NAT gateway is the easiest way to do it. We're going to use the NAT gateway in our lab today. I'm not going to use the NAT instance, maybe down the road, and drop me an email if you think we should do a lab with NAT instances. All right. Now, to finish this lecture part up, you experienced AWS people, you can stop biting your tongues. There are other ways to connect to private services. There are other ways, or Amazon services. There's a lot of ways to have private subnets talk to other things. But this is the introduction. This is the most common pattern there. And I'm not about to set up a lab where we go through Equinix data centers and MPLS, because unless they sponsor and want to give everybody free accounts for all 300 people that are signed up as of today, I don't think that's going to make an effective lab. We'll get to that later. So, in summary, private networks are great. Private subnets are great because then I don't have to worry about the internet accessing my stuff. But sometimes I want those things to be able to talk to the internet to either access Amazon services or to do things like software updates where it's similar to running in our house or running on your corporate network. And to do that, we have those two options. We use the NAT gateway, which is what we're going to use in our lab today, or you could set up a NAT instance. And there are other more advanced things, but they really started getting into the realm of private networking and more advanced architectures for networking than we can do labs with. And maybe someday I'll just do a lecture on that. All right, let's go ahead and jump into the lab. Log into your portal as usual, and we want to go to the test account where we were working last week, at least for those of you that are doing this on a weekly basis. Double check that you are in the Oregon region, and then we want to go to VPC. The first thing we want to do is we want to create 2 additional subnets. Now, if we click on your VPCs, we should still have our CloudSLA VPC, and we've got our subnets within there. But let's go ahead. We want to create 2 new subnets, and these are both going to be our private subnets. So go to subnets and then create subnet. And the VPC we want is our only VPC. And we're going to call the first one SLA.public, or let's call it, private -01. And you know what? I'm going to go back and check the naming of what we named our publics because I forgot. Okay, I just did a quick check and it was SLA-private-1. The availability zone, we do care. We want our 2 subnets to be in different availability zones so we can architect for high availability. So choose 2A. And then for our CIDR block, we're staying within the big IPv4, but we want to break this out, and we're going to go 10.0.3.0/24. And that's going to, if you recall, our last ones were 10.0.1.0. Obviously, the next one's going to be 4.0. I'm not getting too fancy. Then we're going to do that again. We're going to add another subnet. And that subnet is going to be S.L.A.W private 2. Our availability zone we want for this one is 2 Bravo, 2B. And our subnet range is 10.0.4.0/24. We don't need to worry about tags, especially when we use good names. Okay, so we have our first one set. We have our second one set. And now we're going to go create subnet. Now it's created both of these subnets, and right now, if we actually click onto these, you're going to see that they are using the same route table. And so right now, everything can be routed to the internet, and we will get to fixing that in a moment. Let's create our NAT gateway now that we have our public and private subnets set up. Even though right now they all look the same, we will fix that with the route tables. First, we need to go to NAT gateways, and then we create a NAT gateway. And let's call it S.L.A.W-NAT. Now, the subnet part is an important one. The subnet, we don't actually put these in a private subnet the way that it looked like on my diagram. The NAT gateway needs to be in a public subnet because it has to have internet access. So it still needs to use that internet gateway. So we're going to throw it in our public one subnet. And again, the reason we do this is the NAT gateway does need to have internet access to the outside world. And the connectivity type is going to be public. Now, we have to have an elastic IP address. We don't have any created already. So by clicking that button, it actually got one for us, added it to our account, and allocated it for us. We used to be a pain. We had to get the elastic IP first, but the user interface has gone ahead and fixed that for us. If you glance at additional settings, we're not going to worry about that. This has to do with the connectivity type. You can actually set up a NAT gateway that connects back to your private network. We're not going to mess with that at all. We're going to just use a regular NAT gateway, and we're going to create it, and we're creating it in our public subnet. At this point, go ahead, and you're going to need this NAT gateway ID. So copy that out. Because if we go back to our route tables, you'll see that we still only have one route table, and all traffic is being routed out through the internet gateway. The way to fix this is we need to have and create a new route table. So let's go to route tables. I'm curious, I wonder if this lets me copy it. Nope, does not. So we're going to create a route table, and we're going to call it S.L.A.W private route, so we can keep track of things. And then the VPC is obviously the only VPC that we have. Create route table. It automatically adds the one rule that we do need so that anything in here is able to route to local. So for all of the traffic. But this route table sitting there, it's not actually being used by anything yet. We will get there. First thing we need to do is hit edit routes, and we need to add a route. It should not surprise you at all that the route we're going to add is our 000 route. Then the destination is going to be NAT gateway. And you see how it starts to fill it in? And we only have our one NAT gateway. So these are all the settings we need right here. And we click Save Changes. So now this version, all local traffic goes local, just like it did for our one for the public subnets. And all private traffic will now route through the NAT gateway. And a really important thing to remember here about NAT gateways is nobody from the outside can hit these. By default, Amazon has things set up so they ignore all inbound connections. They'll only create and maintain outbound connections. Obviously, return traffic comes through, but nothing can come to these and then get back to our internal network. The thing is, we now have to associate this with subnets because it's not doing anything. So if we go to subnet associations, you can see that we don't have anything set up here. And let's create a subnet association. Now, let's hope I don't mess this up. It's been a while since I've done it this way. I do tend to do this using infrastructure as code. And let's associate with our two private subnets and save the associations. So now if I go to subnet associations, you can see that it's set up to work specifically with those subnets. So let's back this up. By the way, look how nice that is. 1, 2, 3, 4. Sorry, I like symmetry. We'll go back over to look at our subnets, and I'm still selected on my private subnet. And if I hit the route table, you can see now this is truly a private subnet. This can talk to the internet, but it is only going to talk to the internet through the NAT gateway. That's the only way that this is going to work. So this is great. I now have a subnet where I can deploy things like database servers and such, and I don't have to worry about some idiot on the internet attacking those directly. I can do layers and layers of private subnets as well if I want to, and how I can kind of route all of these bits and pieces together. What we have just finished is building a very basic setup, and it's a very common pattern. 2 public subnets, 2 private subnets. The public subnets route through the internet gateway. The private subnets route through the NAT gateway. And yes, unlike my diagram, the NAT gateway lives in the public subnet, but the only things talking to it are within our private subnet. Now we're going to switch gears, and I'm going to show you how to delete all of this so we can save costs. And don't worry, next week I'm going to give a CloudFormation template that's going to replicate this exactly so that we can do the next labs where we need the networking. Going back into my VPC dashboard, I'm going to go to My VPCs. I'm going to select the Cloud S.L.A.W, and I'm going to go Actions, Delete VPC. And it's giving me a warning that it has an in-use network interface and the NAT gateway. So it's been a little while since I've done this. It used to be able to be deleted, the whole thing just from there. But not a problem at all. If I go to NAT gateway and I click on it, and then I go Actions, let's see if delete works or if I have to unallocate the Elastic IP first. Delete, hit delete. So that is now in the process of being deleted. It won't show up right away. That's why you get that state deleting, which can take a minute. The next thing we want to do is make sure that we're not still going to have that Elastic IP address floating around in our account. And so we go to Elastic IPs. By the way, when we get to CloudFormation, creating and destroying is going to be a lot easier. We don't have to do it manually. And you'll notice that it's not associated with anything right now. So I'm going to go to Actions and Release. And it looks like I still need to wait a little bit because the NAT gateway has not been finished deleting. So I'm going to pause the video. And actually, let me show you where to track that. I'm going to go to the NAT gateways. We still are deleting here. And I'm going to pause the video, keep hitting refresh in the background until this is done, and then we can release that Elastic IP address. It took about 3-ish minutes for this to finally be deleted. Let's go back and see if I can release that Elastic IP address. Again, I don't want to be paying for it. We'll hit refresh here. And then we do have an allocation ID still. So let me see if I, whoops, accidentally clicked. Let me go back to Elastic IPs. Okay. And so let's release the Elastic IP address. It's still tied, so give me a moment. I'm going to give this a sec and we'll come back to it. Actually, I think I was making a mistake. Let's go to Actions. And, see, I should be able to disassociate it so that I can get rid of it. Let me try release again. Looks like it's a little bit blocked. I'm going to pause. Apologies as I work through this. These things just happen sometimes. It's a matter of timing on the back end within AWS. Didn't really do anything special. I just gave it a little bit of time. Let's see if it works this time. You'll notice that before associate was grayed out and I couldn't associate or disassociate. Now I can associate. So that means it's not tied to anything. And that's what you do. You get one of these IP addresses and you say, hey, you NAT gateway, you get this IP address. So I should be able to release Elastic IP address. Yep, it says will be released. That error's gone away. I release it. I'll no longer be billed. Now we can go back into our VPCs, and this is actually going to be an interesting one. Let's instead go to route tables. And if I go to my S.L.A.W private route that we created and look at routes, then you'll see that it's still pointing to that NAT gateway, even though it's not there anymore. This is still AWS clearing it out. Eventually, that would turn into a black hole, and you would actually see that it would tell you that it's not going anywhere. Let's go to your VPCs. Let's go to Actions, Delete VPC. No errors this time. It says it will delete everything. And you can play with this if you want for as long as you want. I'm not responsible, but also understand that we're going to have some name conflicts if you leave this in there, because these are the names I'm going to use when I create our CloudFormation next week. All right. If I go back to the VPC dashboard, you can see I have nothing left here anymore. I do have the NAT gateway still listed, but if I go in to check on that, you can see that it lists as deleted. It will just get cleared out. You can see, I mean, it doesn't have that IP address or anything. It's just the back end of AWS catching up with the work that we already did. Hopefully, this makes sense. We created 2 new subnets. We called those private subnets. We created a NAT gateway, which does get placed in the public subnet, but it's for access from the private subnets. And then we altered our route table. We created a new one. So instead of routing traffic through the internet gateway, it's going to route traffic from those subnets to the, instead of routing traffic to the internet gateway, it's now going to route traffic to that NAT gateway. That is it for this week. I'm going to show you some more examples about how to do some of this stuff in the coming weeks as we kind of dig into our networks and our workloads. Hit me up if you have any questions.